Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to write formulas from ionic compounds. So let's get into this. So in my last video I showed you how to write the name from the formula. This time I'm going to show you how to write the formula from the name. We're just going backwards. In this case you're going to take the two parts of the name and write the formula for each ion. And then you have to figure out the balancing of the charge. And there we're going to use the crisscross method. So let's get into this. So for A, we have aluminum chloride. So we're going to write down the ions for each part of the name. So we're going to start with aluminum. So aluminum is on the periodic table. It's in group 3. So if we follow the strategy, we need to know what the charge on aluminum is. It's in group 3, so that means it's going to lose 3 electrons to be like the noble gas. So by losing 3 electrons, it's going to have a positive 3 charge. So we write Al3+. Next, chloride. Chloride is a monatomic ion. It's chlorine with a charge. It's negative. It's going to be in group 7, or it is in group 7. So because it's in group 7, it has 7 valence electrons. It wants one more electron to be like the noble gas, the closest noble gas. And so by gaining that 1 electron, it's going to have a -1 charge. So we write Cl-. Now we do the crisscross method to get the compound that is neutral. So remember, all ionic compounds have neutral charge, which means the total positive charge and the total negative charge are equal. So to make sure that happens, we do the crisscross method. So what is that method? We're going to take the number of the charge for the aluminum, the positive ion. We're going to put it as a subscript for the chlorine. And this is a 1 here. We don't write the ones, but we're going to write the 1 down here. So that's going to be a subscript 1. But again, we don't write ones, so it's just going to be Al and then Cl3. So that, ladies and gentlemen, is the formula for aluminum chloride. Next, let's do B, chromium 3 oxide. So again, we're going to write the ions for each part of the name. So the first ion is your chromium 3 ion. So remember, the Roman numeral indicates that there is a 3+ charge. So we're going to write Cr3+. And then we have the oxide ion. The IDE ending tells us that it's a monatomic ion that's negative. It comes from oxygen. So we're going to write down O. And because oxygen is in group 6, it's a main group element, so it's only going to have 1 charge. And we should know that charge is going to be a 2 negative charge because it's in group 6. It needs 2 more electrons to be like the closest noble gas. So it's going to gain those 2 negative electrons and going to have a -2 charge. So here we write 2-. And now we can do the crisscross method. So we're going to take the 3 here, put it as a subscript for the oxygen. Take the 2 here, put it as a subscript for the chromium. And then we have Cr2O3. And there is the formula for chromium 3 oxide. Let's go on to C. C, we have calcium nitrate. So first, we're going to write down the ion for calcium. Calcium is a representative metal or a main group element. And so we know that's going to only have 1 charge. It's in group 2. So it's going to lose 2 electrons to be like the closest noble gas. And so it's going to have a 2+ charge. So it's going to be Ca2+. Nitrate is a polyatomic ion. You've just got to know the formula and the charge on your nitrate. The formula is NO3 and the charge is a -1. So it's NO3-. So now we do our crisscross method. So here we have the 2 is going to go down here as a subscript for the nitrate. The 1 here is going to go down here as a subscript for the calcium. We don't write the 1s, so it's just going to be Ca. And then since we have two nitrates, we're going to have to use parentheses. So it's going to be parentheses, NO3, close parentheses, and the 2 goes there. And that is the formula for calcium nitrate. D, ammonium sulfide. So again, we're going to start with the first name. That's our first ion, ammonium. Again, it's a polyatomic ion, so we need to know the formula and charge of our polyatomic ions. And so the formula for ammonium is NH4 plus. And the sulfide ion, notice that we have the IDE ending, so that's going to be a monatomic ion. Don't confuse this with sulfite, ITE, that's a polyatomic ion. We're not dealing with sulfite here. This is a sulfide. So remember, that's going to come from the name of the element, sulfur. So that's S. And so sulfur is in group 6. It's a main group element. We should know the charge based on its periodic table, where it is. And so sulfur being in group 6 has 6 valence electrons. It's going to want 2 more electrons to be like the closest noble gas. And so it's going to have a 2 negative charge, just like oxygen, right? So oxygen and sulfur are in the same group. We would expect them to have similar properties, and therefore they're going to have similar charges. So we have a 2 minus charge there. Now we do our crisscross method. So the 1 here is going to go down as a subscript for the sulfur. And the 2 is going to be a subscript for the ammonium. So when we write that, we're going to have 2 ammonium. So we need our parentheses. So that's going to be NH4, 2. And then since we only have 1 sulfur, we're just going to write X. So there's the formula for ammonium sulfide. Okay, so aluminum oxide. Again, aluminum, metal ion. It's going to have a 3 plus charge just like it had up here because it's in group 3. It's going to lose 3 electrons to be like the noble gas. So that's going to be aluminum 3 plus. Oxide again, we had oxide up here. Again, it's going to have a 2 negative charge because it's in group 6. It's going to gain 2 electrons to be like its closest noble gas. So 2 minus. Again, and then we do the crisscross method. So the 3 goes as a subscript for the oxygen. The 2 goes as a subscript for the aluminum. And we get Al2O3. And there's your formula for aluminum oxide. Cobalt-3 fluoride. Okay, so cobalt. Cobalt, again, my favorite element. So cobalt-3, 3, Roman numeral, always tells us the charge, not the number of the ion, just the charge on the ion. So cobalt is CO. CO for cobalt. We know it has a 3 plus charge because of the Roman numeral, so we're going to put 3 plus. And then we have fluoride. The IDE ending tells us it's a negative ion, monatomic, comes from fluorine. So fluorine is in group 7, 7 valence electrons. It needs 1 more electron to be like a noble gas, so it's going to gain a negative electron, and so it's going to have a negative charge, a -1 charge. And now we do the crisscross method. So the 3 goes as a subscript for the fluorine, and the 1 here becomes a subscript for the cobalt. We don't write 1s, so this is going to be CO, and then the 3 for the fluoride ion. And there is the formula for cobalt-3 fluoride. Now, one thing I didn't mention and it hasn't come up just yet is when you do the crisscross method, make sure that your subscripts that you put are the lowest common or the most reduced or simplest form. right? So 1 to 3, I can't reduce that anymore. 2 to 3, I can't reduce that anymore. 2 to 1 is the simplest. 2 to 1 is the simplest, and so on. If you get like a 2 to 2, then you need to reduce that to a 1 to 1 ratio. If you get 2 to 4, then you're going to need to reduce that to a 1 to 2 ratio and change the subscripts. And make sure that if you have parentheses, you're using the subscript that's outside the parentheses. And don't reduce any of the subscripts that's part of a polyatomic ion. So for example, NH4, you don't change that 4, right? Or if you have NO3, that 3 stays a 3. You're not going to reduce that. Okay, so we have iron 2 sulfate. So iron 2 sulfate, iron 2, the 2 tells us the charge. This is a transition metal, so it's going to be a positive 2 charge on the iron. So we write Fe, and it has a 2 plus charge. And then we have sulfate, a polyatomic ion. You got to know the formula and charge of the polyatomic ion. So SO4 2 minus. Now we can do our crisscross method. So we're going to put a 2 here. And then this 2 goes down here. So if you write this, it would be Fe2. And then since we have 2 of these, we have to use parentheses. So it would be SO4 2. Now notice here, I was just talking about reducing your subscripts. So here we're looking at 2 and 2. We're not looking at the 4. That 4 is part of the polyatomic ion. We're not doing anything with that. But it's this 2 outside and this 2 here. So notice that 2 to 2 can be reduced and simplified to 1 to 1. So that is going to be our final one. So we're going to reduce that to 1 to 1. So our final formula is going to be FeSO4. So that's our final formula. Next, we have ammonium hydrogen phosphate. So look, it looks like we have 3 names, but remember there's only 2 ions. So the first name is your first ion. The rest of it is your second ion. This is a polyatomic ion you need to know. So again, ammonium, same as before. Ammonium is NH4. So we're going to write NH4 plus. And then hydrogen phosphate, again, if you can't remember, just remember what phosphate is. You should know at least phosphate. Phosphate is PO4 with a 3 minus charge on it. And hydrogen tells you that there's 1 hydrogen. If this was dihydrogen, then you would have 2 hydrogens. And if you remember about hydrogen, if you have a hydrogen ion, it has a plus charge on it. So if you have 1 hydrogen, that's 1 plus charge. You should know that there's a 3 minus charge on your phosphate, PO4 3 minus. If you add a plus 1 charge from your hydrogen to the 3 minus, then that will cancel out one of the negatives and you get a 2 negative charge on the ion that is made up of your H and your PO4, and that's the formula. So that's going to be HPO4 2 minus instead of a 3 minus. Why? Because you can think of it this way, that hydrogen has a plus 1 charge. It's going to cancel out one of the 3 minuses, and you get an overall charge of 2 minus. So you can kind of think of it that way, if that's helpful. Now, all we need to do is do our crisscross. So here, this 2 goes down here as a subscript. The 1 goes down here as a subscript. And so we write the formula. I'm going to have to erase it to give myself some room. So we have a 2 down here. So we're going to have 2 NH4. So we're going to need to use parentheses for this. So this is going to be NH4 parentheses 2 and then HPO phosphate. That should be a PO4 like so. And so that is the formula for ammonium hydrogen phosphate. And then finally, we have potassium bicarbonate. So potassium is a metal. It's in the first group. It's a monatomic ion. It's just the name of the element. So we know it's going to be K for potassium. And since it's in group one, we should know it has one positive one charge because it only has one valence electron. It's going to lose that electron to be like the closest noble gas. So it's positive. And then bicarbonate, you should know that's the polyatomic ion. Bi is referring to the fact that it has two hydrogens. Another name of this is dihydrogen carbonate. So dihydrogen carbonate, again, if you have trouble remembering the formula and the charge on this, just remember carbonate. Carbonate, you should know, is CO3 2 minus, right? And if it's bi or dihydrogen, then you know it has two hydrogens. Each hydrogen you can imagine has a plus charge on it. So the bicarbonate is going to cancel out there. So the bicarbonate is going to be H2CO3. Give me a second. Sorry about that. I made a mistake. This is actually HCO3. So bicarbonate only has one hydrogen. So again, CO3. So carbonate has two negatives. And so if you have one hydrogen on there, then you subtract a negative, and now it has just one negative on there. I made a mistake with regard to bi. Bi is actually goes back to an older way of naming the substance. Bicarbonate indicates that it takes twice as much carbonate for the bicarbonate ion to react with potassium. So you need twice as much. So that's what the bi comes in. So twice as much carbonate. So here you've got potassium, you got your bicarbonate or hydrogen carbonate ion. Your hydrogen carbonate or bicarbonate is going to match with this. You got a plus, you got a minus. This is -1, so you're going to get a 1 down there, and you're going to put a 1 down there for the crisscross method. And so you have one each. We don't write the ones. So the final formula is going to be CO3. HCO3. Okay, so there's your formula. Sorry about the hiccup on that one, my bad. So that's how you write the names of your ions, your ionic compounds, or the formulas for your ionic compounds from the name. So I hope this was helpful. If it was helpful, then please, by all means, like the video, share the video. Also, make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have any requests, if you want me to cover a topic, or if you want me to solve a problem for you or answer a question, I would love to hear from you. Thanks for joining me, and have a great day.